Yeah, we can.
Oh, sorry about that. But the first part was just a revision.
We can't see anything.
Voice
The
so
camera is
blurry.
bad.
What do you mean the camera is bad?
It's okay now.
Maybe there's a problem with the internet. Any more questions?
Nah.
Today we have a lot to discuss, and a lot of time has passed. So today I want us to discuss simplification. Let's discuss simplification of rational
So we can see up there in sofa.
expressions.
Excuse me, sir.
Then we will discuss addition. And
Mr. Professor, we can't see anything apart from 2 and 1.
Okay, that's it.
don't worry, I will do it again. So one, I put simplification. Simplification. And then we will look at multiplication. These are pretty simple. Division. Then compound fractions. How do you simplify them? Compound fractions. And lastly, rationalization of numerator and denominator. These concepts are very simple because we are dealing with rational expressions which are essentially fractions, polynomials. Some properties of fractions will be helpful in this case. So for example, simplification.
Excuse me.
Is someone talking?
Yes, I can see your writing is a bit small, especially from number, I think it's 4, 5, 6. I don't know what you've written.
Number 4 is division. Number 5 is compound fractions. And number 6 is rationalization of numerator and denominator. This bit is not important. I'm just giving you a hint of what we are going to discuss. But this bit is not really important. So simplification, for example, we want to use the property of fractions that if you have AB divided by BC, then you just cancel out the common term, which is B in this case, and you get A divided by C. So when simplifying these rational expressions, you want to write it in the lowest term. So you want to have irreducible polynomials. So polynomials which cannot be factored further. For example, suppose you have the expression x squared minus 4x plus 4 divided by x minus 2 times x plus 2. Okay. Simplify this expression. We want to write it in the simplest form. So such that the numerator and the denominator are irreducible, cannot be factored further. And in this case, we are lucky the denominator has been factored already. You cannot factorize x minus 2 and x plus 2, at least in the real line. Maybe the complex plane you could. But we can factorize the numerator. So the first stage is factorize numerator. Factorize x squared minus 4x plus 4. This is a quadratic expression, and you know how to factorize quadratic expression. Look for two numbers whose sum, in this case, is the coefficient of x, -4, and the product is 4. Okay, -2 and -2 will work because -2 minus 2 is -4, -2 times -2 is 4. So this simply means you could write -2 as -2 minus 2. So that instead of x squared minus 4x plus 4, we have x squared minus, so where there is minus 4x, we replace with minus 2x minus 2. This is just another way of writing minus 4x plus 4. Then now group the terms. Okay, so in the first term, the common term is x.
Excuse me, Mr. Professor. Push the camera behind a bit. We can't see some of the digits. Like at the extreme end, like the equation that says x squared in brackets minus whatever. Yeah, yeah.
That's better.
Yeah.
So the first group, we have x factors x squared x times and factors 2x twice, and then minus, so the common factor in 2x and 4 is 2. So we have 2 outside, and then 2 into 2x, that is just x. -2 into 4, it's -2. Okay, so you have x minus 2 as a common factor, and you pull it out, you get x minus 2 into x minus 2. Okay, so the numerator factors as x minus 2 times x minus 2. So what we have is now x minus 2 times x minus 2 divided by x minus 2 times x plus 2. Then the property that we have here is that you will cancel out common terms, so p and p. In this case, x minus 2 and x minus 2, and we will have x minus 2 divided by x plus 2. This is the simplest form of this expression. You cannot factorize the numerator further. You cannot factorize the denominator further because they're just linear polynomials. So to simplify any rational expression, the idea is to factorize each of the terms. Factorize the numerator if it is possible, and factorize the denominator if it is possible, and then divide the common terms in the numerator and the denominator, and leave your answer as the simplest irreducible form. Is that clear?
Yeah, sir. Excuse me.
Go ahead.
Could you go over from this part here?
Which
We
part?
go over from x, what x, I just says open x minus 2 minus 2x, x minus 2. We go over from here.
Here.
Yeah. Yes, from there.
Did you get up to this point?
Yes, I got up to that point.
Okay. Maybe the best we can do is to split out this term. So factorize first x squared minus 2x. The common factor in x squared minus 2x is x. Okay. When you pull out x from x squared you get x. When you pull out x from minus 2x, you get minus 2. So x squared minus 2x is equivalent to taking x times x minus 2. Is that okay?
Okay. Yes, it's okay.
Then the second part, minus 2x plus 4. The common factor in this case is -2. So we want to pull out -2. -2 into 2x, we get x. And then -2 into +4, we get
-2.
-2. So now what we have now, instead of x squared minus 2x, we have x multiplied by x minus 2. And instead of -2x plus 4, we have -2 into x minus 2. Okay?
Yeah.
Then at this stage, you do factorization. You see x minus 2 is a common factor. We have x minus 2, we also have x minus 2 there. So pull out the x minus 2. X minus 2 into the first expression, x. Into the second expression, you get -2.
Oh, so you're saying x minus 2 goes into the first expression, you'll be left with x.
Final expression will be?
Pardon? You said x minus 2 goes into this first expression, you'll be left with x. Just go over this part right here.
I don't think I understand what you're saying.
Yeah, just go over the factorizing part right here.
This one?
Up here, yeah. Just the factorizing part.
Yeah.
No, right here.
Yeah.
No. X parenthesis x minus 2 minus 2x minus 2. That's what you should do. Yeah. Just go over that part, please.
I do what?
Could you go over that part, please?
So your problem is factorization from this stage?
Yeah.
Okay. Let me see if I can solve the problem. You have x into x minus 2 into x minus 2. Now, what I will do, let t be x minus 2. Okay? So this x minus 2, I want to call it t. So I will have x times t minus 2 times t. Is that okay? Then now, we factor out t from this. So we pull out t goes into xt, x times into minus 2t minus 2. So finally, you have t into x minus 2. But what was t? T was x minus 2.
Yes.
So we finally have x minus 2 times x minus 2. Are you happy now?
Yes.
Great. Let us proceed. I will combine addition and subtraction because the procedure is the same. Addition and subtraction. Addition and subtraction. Rational expressions. So in general, if you have two expressions, a divided by b plus or minus c divided by d, you'll proceed as you normally do with fractions, find the LCM. So this should be the LCM of b and d as your common denominator. Then you ask yourself, how many times does b divide the LCM? To divide it, the LCM BD divided by b, you multiply this by a, plus or minus. How many times will d divide this LCM? It will divide it, the LCM of b d divided by d, multiply that by c. This is how we treat fractions. The procedure is the same when you're dealing with rational expressions because they're just fractions of polynomials. For example, let's say you want to simplify maybe x divided by x minus 1 plus 3 divided by x minus 2. Okay? you want to simplify this. You want to combine this, to write this as a single fraction, or just to add them. So the first stage is to find the LCM. The LCM of x minus 1 and x minus 2. What is the LCM of x minus 1 and x minus 2? What would the LCM?
x1 and x multiplied by x2. X minus 2, sorry. X minus 1.
X 1, x minus 2 is the product. It's x minus 1 times x minus 2. Now we want to write this fraction, the common denominator x minus 1, x minus 2. So then x minus 1 divides the LCM x minus 2 times. So we will have x times x minus 2 plus x minus 2 will divide the LCM x minus 1 times. So we will have 3 times x minus 1. Okay. And then now expand this. So x times x, that is x squared. X times 2 is minus 2x. 3 times x is 3x. 3 times negative 1 is negative 3. All this divided by x minus 1, x minus 2. Of course, this can be written as, so when you combine negative 2 and 3, you get 1. So this is the same as x squared plus x minus 3 divided by x minus 1 into x minus 2. And you will not be able to factorize this. This x squared plus x minus 3 cannot be factorized in the set of reals unless you are dealing with complex numbers. So you leave your answer at that stage because you cannot factorize the denominator. If it was, if we could factorize it, we would factor it and then see if there's a common factor, and then we simplify what we have. But in this case, the denominator is an example of a prime polynomial. You cannot factorize, just like prime numbers cannot be factorized. This is an example of a prime polynomial. You cannot factorize it. Okay.
Excuse me, sir.
Go ahead.
Could you kindly repeat the part right after you found the LCM?
Which part?
After you, where you've written x into bracket x minus 2 plus 3 into bracket x minus 1.
Yeah.
Not there, above.
Up.
Not there, above the equation.
Yeah.
Right, yes, there.
Yeah.
Under that now.
Yeah, so I started by finding the LCM of the denominators, which is just happens to be their product. Okay. Then now, just the way you add fractions. How do you add fractions? For example, I gave you, if I gave you 2/3 plus 5, maybe, I don't know, 5 maybe. How will you add these fractions? First of all, find the LCM of 3 and 4, which happens to be 12. Okay.
5 2.
How many times will 3 divide 12? It's 4. 4 times 2 plus, how many times will 4 divide 12? 3. So you take 3 times 5. And then you just get 8 plus 15 divided by 12. And that gives you 23 divided by 12. That is the exact same thing we're doing here, except that we're not dealing with the numbers, we're dealing with polynomials. So LCM is x minus 1, x minus 2. Now x minus 1 will divide this LCM x minus 2 times. So we take x times x minus 2 plus x minus 2 will divide the LCM x minus 1 times. So we take x minus 1 times 3, which is what we have here. Then now I've just opened the brackets. So x squared, then x minus 2 is minus 2x, and then 3 times x is 3x, 3 times -1 is -3. So this is going to, then I combine like terms, 2x and 3x. So minus 2x plus 3x gives you x squared and minus 3 as they were. And then we have this denominator, x minus 1, x minus 2. Okay?
Okay.
And then you can factorize. If it is possible to factorize, you can go ahead and factorize. Okay? Hello?
Yes, it's okay, sir.
Hello.
Any more questions? So you will do the same for subtraction. The logic is the same, okay? Just that now you will have a sign for subtraction. Maybe let us do one example on subtraction. One example on subtraction. So suppose you have, maybe, I don't know, x minus 1 divided by x plus 1 squared minus maybe 3x plus 5 divided by, I don't know, x squared minus 1. Okay? We want to simplify this expression. So essentially it's a subtraction of two rational expressions. So this is a polynomial. The denominator is also a polynomial. We also have the same for the second term. So the first step is to find the LCM. LCM of x plus 1 squared and x squared minus 1. What is going to be the LCM? What's the LCM?
X.
X plus 1 squared and x squared minus 1.
Are you sure?
X plus 1 squared.
Are you sure?
Let me see. Move on.
So x plus 1 can divide both terms, right? So x,
Yeah.
the first expression you get x plus 1, and then x plus 1 into x squared minus 1, we'll get x minus 1.
X minus 1.
Okay? And then again, x plus 1 can divide x plus 1, but it cannot divide x minus 1. Then x minus 1 can divide x minus 1 once. So the LCM will be this product. So our LCM is going to be x plus 1 squared times x minus 1. Okay? And now you will have a common denominator, x plus 1 squared times x minus 1. And by the way, at this stage, I think it's important to point out that any other denominator you use will always work. So someone could also take the product of the denominators. If you use x plus 1 squared and x squared minus 1, you will still get a similar answer, only that at some point you will have to do factorization. But if you use the LCM, you will not have to factorize the denominator. If you do not use the LCM, in most cases, if especially if these terms happen to have a common factor, like in this case, x plus 1 is a common factor for the denominators. If we did not use the LCM and instead opted to use this product, then we will have to factorize the numerator further. But if you use the LCM, there will be no need for factorization. So x plus 1 squared divides this expression, x minus 1 times. So we will have x minus 1 multiplied by what we have here, x minus 1 minus, so we have 3x plus 5. We need to multiply that by x squared minus 1 times this expression. So how many times does x squared minus 1 divide this LCM? That's not a trivial, it's not a trivial question. So you need to compute x plus 1 squared times x minus 1
Excuse me, sir.
squared minus 1. Yes?
May you please, I'm a bit lost from where you are doing now after you got the LCM, how you got x minus 1 times x minus 1 minus 3x plus 5. Could you please repeat that bit?
Yes, you can repeat. So we have the LCM. I said the same logic that you use for fractions of numbers. It's the same logic we are applying here. So how many times will x plus 1 squared divide this LCM? I'm asking you, it's a question. How many times will x plus 1 squared divide this expression?
Once. 1.
Really? And there is this guy.
X minus 1.
But we'll have x minus 1 left.
Yes, so you will have x minus 1 as the quotient.
Yeah, x minus 1.
So we take that x minus 1 and then multiply by the
X minus 1.
The numerator we had was?
Wait, sir, so this x plus 1 squared divides x plus 1 squared once, but then because it's 1 that's left, now that's why we use x minus 1.
No. Not really. So let's do this. Huh? We are doing division. You have x plus 1 squared times x minus 1 divided by x plus 1 squared. Okay?
Yeah.
How do you do division? In this case, you have common terms. Just cancel out the common terms. And your answer is x minus 1.
Okay, I've understood. Thank you.
Fair enough. Good.
Yeah.
So the first x minus 1 is this quotient. The second x minus 1 is what we have in the numerator. Then minus, how many times will x squared minus 1 divide our LCM? So we have our LCM is x plus 1 squared times x minus 1. We want to divide this by x squared minus 1. Okay. The best way to do this is to write x squared minus 1 as x minus 1 times x plus 1. Remember, you can factorize this. This is a difference of 2 squares, right? So you can factor it as a sum and a difference product. So x squared minus 1 is the same as x plus 1 times x minus 1. Then just cancel out the common factors, x minus 1, x minus 1. Then x plus 1 will cancel 1, x plus 1, and you remain with x plus 1. So up here we have x plus 1 multiplied by 3x plus 5, where 3x plus 5 is what we have in the numerator. Is that okay?
Yes.
Are you happy with this stage?
Yes, sir.
Great. So then I will just, actually from here you could proceed. Huh? You just need to expand this and see if you can simplify. So the first term, x minus 1 times x minus 1. I'm just multiplying out this. So I will have x squared minus 2x plus 1 minus, I'm just doing multiplication. So this is the product of x minus 1 and x minus 1. And then now we have here 3x squared plus, so we'll have 5x plus 3x, that is 8x, and then plus 5. All this divided by x plus 1 squared x minus 1. So here I've multiplied x minus 1 by x minus 1 to get x squared minus 2x plus 1. and I multiplied x plus 1 by 3x plus 5 to get 3x squared plus 8x plus 5. Then I open this bracket, so we have x squared minus 2x plus 1 minus 3x squared minus 8x minus 5. All this divided by x plus 1 squared times x minus 1. I've just opened the second bracket, so there is a negative 1, and I use it to multiply everything that is inside the bracket. Then now just collect like terms.
Sorry, sir, before you erase that part. Hello.
Hello, go ahead.
Yeah, so don't you think it's gonna be easier to factorize from that line? The line when you have x minus 1, then expanding. Are we obliged to expand? I did factorize from that point and it's way easier.
Yes, it's way easier to do that, but I just thought it would confuse someone, but it's easier to factorize from this point.
Okay, okay. So it's better to expand in an assignment.
It is not better to expand. You do the method that works for you.
Okay.
You could actually simplify from this stage. Okay.
So that means
Then
if
you
it works for
collect
someone,
like terms there. Is someone talking? So x squared minus 3x squared, that is minus 2x squared. Minus 2x minus 8x, that is minus 10x. And then 1 minus 5 is minus 4. All this we're dividing by x plus 1 squared by x minus 1. Then we will have, I can factor out negative 2. So into x squared plus 5x plus 2 divided by x plus 1 squared times x minus 1. Is this what you got? Did you get this? The person who factorized? Is this your final answer?
Yeah, it's just written differently. I'm trying to compare, but I think so.
Okay. Any questions?
so is it okay if a person takes x plus 1 squared and x squared minus 1 as the LCM? Okay, not as the LCM, but as the denominator.
Yes, you can take that as the denominator, but you will have to factor at some point.
Okay.
You will not arrive at this directly. You will have a numerator which has one of these as its factors, either x plus 1 or x minus 1. And most likely x plus 1 will be a factor because we're taking x squared minus 1. So you will have an extra x plus 1 in your numerator. But it's possible, it can be done. There's no problem. Just like when we're dealing with the numbers, for example, 2 divided by 4 plus 5 divided by 8. Well, I know the LCM is 8, so I could use the LCM. Let's say 4 goes into 8 twice, so 2 times 2 is 4. 8 goes 1, so we'll have 9 divided by 8. But I could also take the product. The product of 8 and 4 is 32. 4 divides 8, divides 32 8 times. So 8 times 2 is 16 plus 8 divides 32 4 times. 4 times 5 is 20. So what we have is 36 divided by 32. But these two guys have a common factor. 4 divides 36, 9. 4 divides 32, 8. So you see, you will still get the same answer, but you'll have to go through this pain of doing another simplification again.
Sir, could you also take 4 as LCM?
Here,
Yeah,
you cannot take 4 because 8 cannot divide 4.
okay, thanks.
Yes. Okay, next is multiplication.
Excuse me.
What?
But two can divide 4 and 8. So what if you just broke it down from there? It would, I think it would still take you back to.
What did we have? What did we have? We had
I still don't remember, but it wasn't the denominators was
something.
4 and 8.
Then
So
I don't know whether this was 3
yeah,
or 5. I don't know. I'm not sure.
like the LCM of 4 and 8, I think it's like a 2. What if you just simplified it from there and then still
LCM
give
of
it
4 and 8.
yeah,
What is the LCM of 4 and 8?
it's a 2.
8.
I think
2.
4.
it's 2.
You're confusing LCM and GCD.
The GCD is 4, isn't it?
The GCD is 4.
Yeah.
But the LCM is?
It must be,
LCM is 8.
yeah, 8.
LCM, you're taking multiples. So what are the multiples of 4? The multiples of 4, 8, 12, 16, 20, on and on. The multiples of 8 are 8, 16. What else do we have? 24, 32, 40. Then you look for the smallest. So the smallest in this case is, the smallest which is common is 8. 4 is not common. But GCD, you look for the divisor. This is LCM. Divisors of 4 are 1, 2, and 4. Divisors of 8 are 1, 2, 4, and 8. Then you take the greatest, which is common. So 4 is common and it is the greatest. Multiplication of rational expressions. So for multiplication, it's very simple. That's the way you multiply two fractions. Let's say A divided by B times C divided by D. It's the same way you multiply rational expressions. Just take A times C divided by B times. So you multiply the numerators, multiply the denominators, and see if you can simplify further by factorization. For example, let's say you have x minus 1 divided by x squared minus 4. You're multiplying this by 3 x minus 2 divided by, what should we put here, divided by x squared plus 1. Yes, you want to multiply these two expressions. So just multiply the numerators independently, then multiply the denominators independently, and then see if you can factorize. So we have x minus 1. We are multiplying this by, so I can already open up this bracket. Huh? So 3 times x minus 2 is the same as 3x minus 6. We're dividing by, we want to take the product of x squared minus 4. So this is going to be, because you're doing x squared minus 4 times x squared plus 1. So the first, you will have x times 3x is 3x squared. X times 6 is 6x. Negative 1 times 3 is minus 3x. Negative 1 times 6 is plus 6. Then divide by. So x squared times x squared is x to the 4. Then x squared times 1 is x squared. Then we take -4 and multiply all these terms. So -4 x squared, and then lastly -4. Okay, then collect like terms. So up we have 3x squared minus, so we can combine 6x and 3x to get minus 9x, then plus a 6. All that divided by what you have here is x to the 4 minus 3x squared minus 4. Okay, let's see. Is it possible to factorize this? So up here, we can write this, we can factor out 3 from the numerator. So we get 3 into x squared minus 3x plus 2.
Excuse me, sir.
Numerator, go ahead.
I have a question. How did you get 3x squared minus 9x? The 9x part, how did you get that from?
The 9x is minus 6x minus 3x.
Oh, minus 3. Oh, okay. I thought that you had written, that looked like 5 for a second. Sorry. Yeah, I have understood now.
It's a minus 3 from minus 1 times 3.
Okay.
Great.
Thank you.
Sorry, I have a question.
Go ahead.
So from the first line, is it okay to say that x squared minus 4 can be written as x minus 2 times x plus 2, right?
Yes, yes. So, I mean,
And then from there, I can cancel out the x minus 2s.
that is the simplest way to do it. You take x minus 1 times 3 into x minus 2.
Yeah, it's
minus 2 into x plus 2 into x squared plus 1. And then now you cancel out.
You cancel out the x minus 2.
And you will arrive at 3 x minus 1 divided by x plus 2 into x squared plus 1.
Yeah.
Yes, that is the simplest way to do it. I've decided to take a longer route. Okay. But you could arrive at the answer in just one stage. Okay, so let's see. Go ahead.
How did you arrive the x minus 2 bracket x plus 2?
Okay.
That stage.
Yeah.
They said no above.
Yeah.
No, they said that you were it right now.
Yeah.
Not, no.
Which part?
Here, the left side.
She's
Yes, yeah.
Someone asked if there's an alternative way of doing this. And I said, yes, there is. You do not have to expand this. Just write x squared minus 4. So remember, this is a difference of squares. You could write x squared minus 4 as x squared minus 2 squared. And you know that will factor out as x minus 2 times x plus 2.
Yes.
Then x squared
Yeah,
plus 2. Then just cancel out the common terms, x minus 2, x minus 2. And in the numerator, we'll have 3 into x plus 1. Then down here, we'll have x plus 2 and x squared plus 1.
Yeah, thanks.
Are you happy? Okay, so in the numerator, I've factored out 3. And now we need to factorize the denominator. We need to factorize the denominator. So what I will do in the denominator, so you have x4 minus 3x squared minus 4. Let x squared be something, let's say y. And of course, you know that x to the 4 is the same as x squared squared, so that will be y squared. So the same expression in terms of y will be y squared minus 3y minus 4. And now you can factorize this. It's a quadratic in y. So you look for two numbers whose sum is -3 and product is -4.
Sir, I'm a bit lost.
Where are you lost?
Like from the beginning actually. Could you
From the beginning.
yes, could you write like maybe at the middle of the board? I can't see at the edge.
At the edge here.
Yeah.
But you're okay with you're okay up to this point.
Yes.
Good. So maybe we don't need this. You have it. I can drop this part. Huh?
Yes.
Okay. So we want to factorize the denominator, and our denominator is x to the 4 minus 3x squared minus 4. Remember, we have not done factorization of fourth powers in this class. You could factorize fourth powers if it's possible, but in this class we have only done up to quadratics. So we up to cubic, sorry, where we did difference of cubes and sum of cubes. But here we are getting a quadratic expression, polynomial of order 4. You could make the substitution that y is x squared. Okay. And also remember that x to the 4 is just x squared squared. But if your x squared is y, so this will be y squared. So then writing this expression in terms of y, where there is x to the 4, we will replace with y squared. So we have y squared, where there's x squared, replace with y, then minus 4. Now this is a quadratic in y, and we have done factorization of trinomials like this, which are quadratic. So we said you look for two numbers whose sum is -3 and product is -4. Well, -4 and 1 will work. If you take -4 plus 1, you get -3. If you take -4 times 1, you get -4. So that means you will have y squared minus 4y plus y minus 4. So you see minus 4y plus y gives you minus 3y. Then group these expressions. So in the first group, y is common. So we factor out y into y squared, it factors as y. And into 4y, it factors as -4. Then the only common term in y minus 4 is +1, which gives you y minus 4. And so what we have so from here, we can factor out y minus 4. So we have y minus 4. The first expression, we have y. Second expression, we have +1. So we have been able to factorize y squared minus 3y minus 4 as y minus 4 into y plus 1. But remember that our y is x squared. So going back to the variable y, we will have here x squared minus 4 times x squared plus 1. This is because y is x squared, right? So here we have x squared minus 4 times x squared plus 1. That's our denominator. And you could also factorize the numerator. This is a very familiar polynomial now. We have factored it, I think, more than 5 times in this class. Two numbers whose sum is -3 and product is 2, -1 and -2. So we will have 3 into x minus 1, x minus 2 divided by x. Instead of x squared minus 4, we'll have x minus 2 times x plus 2 times x squared plus 1. So x minus 1 and x minus 2, this is just factorization of x squared minus 3x plus 2. The procedure is the same as we did over here. Look for two numbers whose product is 2 and sum is -3. So if you take -1 and -2, -1 times -2 is 2, -1 minus 2 is -3. So this factors as x minus 1 times x minus 2. And there's a 3 up here. And then x squared minus 4, which we obtained from this factorization, is a difference of squares. So you could write x squared minus 4 as x squared minus 2 squared. So x squared minus 2 squared will factor as x minus 2 into x plus 2. This is what I have here, x minus 2, x plus 2, and then x squared plus 1. Then at this stage, if there are any common terms, which we have x minus 2 and x minus 2, and finally you have 3 into x minus 1 divided by x plus 2 into x squared plus 1.
So,
Okay. Go ahead.
with this method, we basically just went back from what we had at the beginning. It's the same expression we had at the beginning. So I think it's important that people know that if you can simplify from the beginning, you better just do it to avoid ending up with terms like x to the power 4, x to the power 6, and you don't know how to do it.
Yes, that's a good advice. And I'll advise that you from the word go, just see if it's possible to factorize without having to go through this pen. But this pen is necessary. I needed to show you how to multiply polynomials and how to factorize them. You will find some nice polynomials like this one, which you can factor immediately. But in some cases, you will not find nice polynomials. So you'll have to go through this pen. Any questions? Any questions? Okay. The next operation is division. Division. So just as you did with the fractions, let's say a divided by b, when you want to divide this by c divided by d. Well, the idea is to invert the second expression and then change from division to multiplication. So this should be a divided by b times d divided by b, which is ad divided by bc. We have seen how we do multiplication. So division and multiplication, the logic is similar, only that for division, invert the second expression and change to multiplication, which you have just seen before. So it's very easy to divide polynomials once you know how to multiply this rational expressions. Invert the second term and change to multiplication. It's as simple as that. Do you want an example?
Yeah. Yes.
So let's say you have 3 divided by x minus 6, divide this by, I don't know, maybe 2x 7 divided by x cubed plus maybe x cubed minus let's see, 216. Okay. So I've said that you will invert the second expression and change to multiplication. So this should be the same as 3 divided by x minus 6 times x cubed minus 216 divided by 2x plus 7. Okay. Is it possible to factorize this term?
Yes.
X cubed minus 216. You remember factorization of a difference of cubes? So you could write this as 3 into x cubed minus 6 cubed divided by x minus 6 into 2x plus 7. I hope 6 cubed is 216. You might want to confirm that. Then let me remind you, we said that if you have a cubed minus b cubed is the same as a minus b, a squared plus ab plus b squared, right? So for this case, a is gonna be x, b is gonna be 6. So this top part will factor as x cubed minus 6 cubed will factor as x minus 6 times x squared plus 6x plus 6 squared, which is 36. All this divided by x minus 6 multiplied by 2x plus 7. Then at this stage, you could factor out, you could cancel these common terms. End up with 3 into x squared plus 6x plus 36 divided by 2x plus 7. You could leave your answer at this stage, or you could go ahead and divide. Long division of polynomials. Of course, this is the same as 3x squared plus 18x plus, this is going to 108 divided by 2x plus 7. We can divide because the denominator is linear and the numerator is quadratic. But the answer is, there's no problem if you leave the answer at this stage, but you could go ahead and divide. Let's say you want to divide 2x plus 7. We're dividing 3x squared plus 18x plus 108. Okay, so 2x. How many times will 2x divide 3x squared? That is 3 over 2x. Then take 3 over 2x multiplied by 2x. So this gives you 3x squared plus 3 over 2x times 7. What would that be? That will be 21 x halves. Then subtract 3x squared, that's 0. 18 minus 21 halves. What's that? 18 minus 21 halves. LCM is 2. So you get 36 minus 21. This is going to be 15
over 2.
X over 2, great, plus 108. And then how many times will 2x divide this? The first expression. How many times will 2x divide 15 x over 2? 15 over 2 times a half. So it will divide this 15 over 4. 15 over 4 times 2x, that is 15x over 2 plus 15 over 4 times 7. Let's see, 15 by 7 should be 85, really 105. So 105 divided by 4. So this should be 105 divided by 4.
I have a question.
When you subtract this, go ahead.
So why are you not doing for 7?
Which 7?
2x plus 7.
I did for 7. I did 50. I did for 7.
So how can you divide 7 and 3x squared?
I don't get your. I don't understand what you are asking.
Yeah, you have done for 2x. When you saw when you get 3/2 for
Yes,
2x you got
I started with 2x. Of course, 2x times 3/2x gives you 3x squared.
so for 7 how did you do
Yes,
for 7?
I took 3/2 times 7. That gives me 21x/2. Okay. Then now 15. Now I need to get this difference. So 3x squared minus 3x squared is 0. 18x minus 21 half x is 15 half x plus 108. And then now we are dividing 15x plus 1/8 by 2x plus 7. So we take the first term. How many times will 2x divide 15x over 2? That is 15/4. Then we take this 15/4 and multiply by this dividend or divisor. So 15/4 times 2x, that gives us 15x/2, which is expected. 15/4 times 7 gives us 1/5 divided by 4. Then now get this difference. So there will be no x term because 15 and minus 15 will be additive identity, which is 0. So 108 minus 105/4. 108 minus 105 divided by 4. LCM is 4. 4 times 108, that is 432 minus 105. What do you get? What is this difference? Is it 427?
327.
Yes, 327 divided by 4. So you could leave your answer like that, or you could have 3x plus 15/4 plus, so we are remaining with 327. So plus 327/4. All these divided by 2x plus 7. Could leave your answer at that stage, or you could divide to get that remainder. Both the two forms are accepted. Questions? Questions? So I have done this because 2x plus 7 cannot divide 327/4. You're having a linear polynomial, it cannot divide a constant polynomial. So we'll just leave it as a fraction. Because a linear polynomial cannot divide a constant polynomial. So you leave the second part, the second bit as a fraction. Any question? Anything that is not clear? Compound fractions. So next we have compound fractions. Compound fractions. Definition, these are rational expressions for which the numerator or the denominator or both have fractions. So a compound fraction in rational expression is simply an expression in which either the numerator or the denominator or both of them are fractions. So for example, you could have, let's say 1 plus x divided by z. This is divided by x divided by z minus maybe, I don't know, maybe 5. This is an example of a compound fraction. So you see in the numerator, we have a fraction, x divided by 7. And in the denominator also we have a fraction, x divided by 7. So how do you simplify such expressions? There are two approaches in dealing with this. So in the first way, first method, write each of the components as a single fraction. So write the numerator as a fraction, a single fraction under the common denominator, and also write the denominator as a fraction under a common denominator. Then proceed in the usual way of dealing with rational expressions, division of expressions. So the LCM in the numerator is z. 1 divides z times, plus z divides z once, so 1 times x is x. We are dividing this by the numerator, for which the LCM is z. Z divides z once, so 1 times x is x, minus 1 divides z times, so z times 5 is 5z. And then we have just done division. So we invert and then change the operation. So this should be times z divided by x minus 5z. Z and z cancel, you get z plus x divided by x minus 5z. That is the first method.
So please repeat.
So the idea is to write each term, write the numerator as a single fraction and write the denominator as a single fraction. Then from there you divide these two expressions. So what I've done is I've taken the LCM in the numerator, which is z, and so we have z, then 1 divides z times. So z times 1 is z, and then z divides z 1. So 1 times x is x. We are dividing by what is in the denominator, which is z. So the LCM here is z again. Z divides z once, so 1 times x is x, minus, so this 1 divides z times, so z times 5 is 5z. And then we have said that when dividing rational expressions, you simply invert the second term and then change to multiplication. So I will change this sign to multiplication and then invert this. So I will let the numerator be in the denominator. So instead of x minus 5z divided by z, I have z divided by x minus 5z, and I've changed the division to multiplication. And then now I just cancel the common term. So in this case, we're having z and z. And in the numerator, we remain with z plus x. In the denominator, we have x minus 5z. That is one way of doing it. Okay. The second approach.
So it's time.
It's time. Okay, it's time. So we will stop there. We will proceed from there next time.
Did you read the attendance?